In this video, I will explain the differences between RAG, in-context learning, and fine-tuning, as well as how to choose between them in a project. RAG is one of the most commonly used methodologies. The process begins with a given question, and the first step is retrieval, finding knowledge related to this question. The idea is that this retrieved knowledge might contain the answer to the question. Next, the retrieved knowledge is inserted into a prompt, and a large language model, LLM, is called upon to generate a response. A critical step here is identifying relevant knowledge, which comes from external knowledge bases. These knowledge bases are dynamic in nature, meaning they are frequently updated. For example, a company may have a large amount of business data that changes daily. Such data is well suited for inclusion in a knowledge base. Similarly, news articles on the internet are updated frequently, making them another suitable candidate for the knowledge base. The relevant knowledge in this context can be understood as reference material for solving the problem. This means the LLM already has the ability to solve problems. It just lacks specific background knowledge. By providing this reference material, the LLM can solve the problem effectively. To give an illustrative example, imagine Lucas, an expert in the field of LLMs. He has previously helped many companies solve problems related to intelligent sales. Thus, he is familiar with the sales domain. However, a new company approaches him to help solve issues related to intelligent quality control. Since Lucas has no prior experience with quality control and is not familiar with its processes or pain points, he cannot solve the problem immediately. In this scenario, if the company provides the relevant background knowledge as reference material, Lucas can leverage his existing abilities to solve the problem. This is the essence of RAG. The ability is there, but what's missing is some background knowledge. The essence of in-context learning is using examples to stimulate specific abilities in an LLM. For instance, if we find the LLM lacking in a particular area, such as evaluating whether an article is well written, one solution is to provide it with examples of good and bad articles. By learning from these examples, the LLM can perform the task better. This approach mirrors our daily learning processes. One of the best ways to learn is through examples. For instance, if a colleague does not know how to write a piece of code, the best way is often to provide an example for them to reference. This allows them to solve their problem based on the example. In-context learning does not modify the LLM itself. It simply involves designing the prompt to include examples. However, this approach has limitations. The prompt may become too lengthy, and in some cases, even with numerous examples, the LLM might still fail to perform adequately. Fine-tuning is similar to in-context learning in that both aim to stimulate or enhance certain abilities of the LLM. However, fine-tuning involves modifying the LLM itself to create a new version of the model. The core of fine-tuning lies in the training data used. Data determines the LLM's abilities. To enhance a specific ability, corresponding data needs to be collected and used for training. The resulting ability is embedded within the fine-tuned LLM. In contrast with in-context learning, the examples used to represent the ability are external to the LLM, not embedded within it. To distinguish RAG, in-context learning, and fine-tuning, let's consider an analogy. One corresponds to a person who has strong foundational knowledge but lacks background information for a specific project. The other corresponds to a person whose foundational abilities are insufficient for the project, requiring additional training or examples to enhance their abilities. For example, imagine two people. The first is an AI graduate with strong foundational knowledge of AI, but unfamiliar with the details of a customer service project. With sufficient background information, this person can likely complete the project. The second is a humanities graduate with some exposure to math and science, but no AI experience. Even with background information, this person is unlikely to complete the project without first acquiring foundational AI knowledge. The first person corresponds to RAG, while the second corresponds to in-context learning or fine-tuning, as they require the enhancement of specific abilities. Now let's talk about the difference between in-context learning and fine-tuning. Both aim to enhance the model's abilities, but they differ in approach. In-context learning relies on providing examples to stimulate abilities. If the examples are sufficient, the problem is resolved. Fine-tuning is used when the examples are insufficient or inefficient. Fine-tuning involves systematic training, akin to attending a training course, to improve the model's abilities comprehensively. For example, imagine a person who lacks a specific ability. After being given a few examples, this person has strong comprehension skills and quickly learns what to do, resolving the issue. This corresponds to in-context learning. Now imagine another person who, despite being given 5, 10, 20, or even 30 examples, still fails to grasp the concept. In this case, the person might require a systematic training program, much like attending a course, to gradually improve and ultimately solve the problem. This corresponds to fine-tuning. Additionally, there are cases where providing several lengthy examples within a prompt results in inefficiency. To address this, fine-tuning can embed these examples into the model itself, enhancing inference efficiency and eliminating the need for long prompts. By understanding the differences between RAG, in-context learning, and fine-tuning, we can select the most suitable methodology for our projects.